Hello, everybody. As I'm doing lately, I am starting the broadcast just a couple of minutes early, just because of this glitch in the software, whereby if you don't refresh your screen, you won't see that the broadcast has actually started. So I'll just spend about a minute on stuff that has nothing to do with the actual webinar, just to kill 1 minute of time. This is the second webinar today. We had one earlier today for the, let's say, European centered crowd, whereas this one is for the more US centered users. And last week I was off-site in Italy, and so my setup was a little minimal, not perfect, but now I'm back in my usual location, so I hope that this will go smoothly. And as I said, just killing a minute here until it's exactly 11 a.m. Eastern Standard Time, which it is now. So I'll give it another minute for people to join, and then we'll kick it off. And this is the fifth webinar, the fifth, let's say, episode, fifth chapter. And I hope that people are finding these webinars useful, and that we're helping you getting up to speed with Phi faster. We'll keep them going. We're following roughly the structure of our standard tutorials for learning Phi. So just waiting a couple of seconds more for people to join. We seem to be streaming fine, and yeah. So once again, thank you for joining this week. This series of webinars, and my name is Stefanos. I'm one of the founders of Phenometry and one of the developers of Phi, our freeform surface design tool, which is cloud-based and browser-based, and it's also connected with Onshape, the fastest growing CAD platform on the cloud. So last week I covered pop-outs, holes, bridges, or handles, as we also call them. So these are basically tools that allow you to change your volumes, either create new volume by extrusions, pop-outs, or eating away volumes by building holes, drilling holes through your bodies. And you can find this material on our website. If you go to phi3d.com and click on the Learn tab, you will see all of this material plus a lot of examples and other things. A reminder to everyone to subscribe to our YouTube channel and any other social media you may be using, so we can start having a bit of a following. And today I'll be discussing moving, scaling, dimensioning, and positioning objects. So it's more about how to specify dimensions and position and shapes, either in a freeform way or in a precise, exact geometric way. And as always, you can shoot any questions you have on the chat. I'll be keeping an eye on that, and I'll try to keep a little bit of time at the end for any additional questions. We try to keep these webinars short and sweet, as we say. So I never want to run over half an hour, 30 minutes. So let me switch to the application itself. Here it is. A quick reminder for anyone who hasn't had a chance to follow the previous webinars. Phi is a cloud-based application, so you can run it on any browser. You just need to go to app.phi3d.com or just go to our website, phi3d.com, and that will directly lead you to where you need to go. But we are also very happy to be integrated with the Onshape platform. We are an integrated cloud application. So in this instance, I'm running Phi from within Onshape. You see up here on the left, this is the Onshape environment, and I'm running Phi in a tab. If you run Phi outside Onshape on its own in a browser tab, you can still connect with your Onshape account if you have one, and we strongly suggest that you get one. There's also free accounts if you just want to try it out. And behind the scenes, we can authenticate you through your Onshape credentials with your Onshape account. So even if you're running Phi standalone, you still have access to your documents. You can export, import, do everything you want. So that's very convenient. But you can also run it directly within an Onshape tab, as I'm doing here. And one last thing, in case you haven't checked out Phi yet, but you are an Onshape user, if excuse me, if you click on the App Store icon up here, which you will find in any Onshape document you open, this will take you to the Onshape App Store, which is full of very useful applications that complement Onshape's functionality. And for some reason my browser is stuck. Let me refresh. Categories. Oh, strange. Maybe it's not my browser. Anyway, it seems to be stuck at this moment, but in the Onshape App Store you will find... let me just reopen it. I'm curious now. No, it seems to be a little bit non-responsive at this second. It's okay. You would find Phi in here in the design and documentation category. You click on it, you subscribe, and you have Phi available for you to use inside your Phi environment. So let me go back to the application itself. Now, you will probably have followed some of the previous webinars, and you will see that you will know that you start Phi by loading any simple shape or loading some work that you have already done previously. In this case, I'll just load a cube, as I usually do, and just to help me demonstrate the main things that I want to show. So, as you know, the simplest way to move things around, basically the elements of your design, is just to click and drag them. So I'm clicking and moving around a vertex, or I'm deforming an edge, for example. And the faces, yes, they follow the movement, they interactively adapt to the new shapes of the edges as they deform. However, we very often want to do more precise movements, or we may want to move more than one thing at a time. And that's where the move tool or the move manipulator comes in. So for instance here, I will click on this face to select it, and then I'll hit the move button. And you see this manipulator that came up and was positioned roughly on my face. So this has various elements that I can use. It has 3 axes, which by pulling around, I can translate linearly the selected elements, in this case this face. It has 3 arcs through which I can rotate around the X, Y or Z axis, and it also has 3 little balls which allow me to scale. So here I'm scaling along X, actually along Y I think, and this is along X. But if I keep the shift button pressed as I'm pulling on these balls, I am doing a proportional scale. So I'm scaling in all of the dimensions simultaneously. Now, also we have 3 little planes here which allow you to move within a plane. So this is within the XY, XZ and YZ planes. And finally there's also a little square exactly at the center which allows for a free move. So no matter what view you are in, this is equivalent to, for example, directly moving a vertex. So these are the main elements of the move manipulator. I'll hit M, which is the shortcut for move, and it's exactly equivalent to clicking on the button. To demonstrate one more thing now, instead of just pulling on these axes, you can also just click on them, And if you do so, a little window comes up and you can enter exactly a number, which is how much you want to move in that direction. Similarly, you can rotate by a certain amount in degrees, so let's say 15 degrees here. And you can also scale by a certain amount, like for example 120%. And you saw there was a checkbox for a proportional scale. So this move manipulator, this move tool, allows you to do free-form push and pull operations, but also it allows you to do precise movements, rotations, translation, scales by clicking on it and entering precise values. Now, as you notice, if I click here to switch in a view which is, let's say, down the X, Y, or Z axis, the manipulator is positioned along the global orthogonal axis system. So the red line points vertical, along Z, etc. However, if I hit the L shortcut, for L stands for local, I'm switching into a local coordinate system. So now the manipulator rotated and is placed so that it's along the perpendicular to the selected elements. Now in this case the selected element is just one face and it's not a flat face, but we calculate with adequate precision an average normal to this face and we place the manipulator along that, which is convenient because now you can pull along the normal to this face. If you want to go back to a global positioning, you hit the G shortcut and you're back into the global coordinate system. So L and G help you switch between these two. Alright, now one more thing you can do is select just one vertex and hit M, and you still get the manipulator on this vertex. So this allows you to move it precisely along a certain direction, as I'm doing now, instead of only freeform moving the vertex. But one thing I wanted to point out, if I select, for example, 3 vertices and hit M, the manipulator will be placed on the first vertex I selected, but the movement will be applied to all of the selected vertices. So this is a convenience for moving many things together. And by the way, in case you didn't know this, if I select various vertices and then move one, all of the selected vertices also follow the moving vertex in a rigid way. So this is also a similar convenience. This is something that not many people are aware of. Back to my manipulator, I hit M to bring it on. I can also do one more thing. As I said, if I move, if I push this axis, I'm doing a translation. Now, if I push this axis, but I have the Shift key pressed, our usual friendly modifier, what happens is that the manipulator moves, and the same can be done by rotating, etc. So I'm moving my manipulator, repositioning it without moving the body. And now that I'm here, the application of the movement to the body will happen around this location. So this gives us a lot of flexibility to position the manipulator anywhere in space and then apply movement based on that position to the body. And one more thing, I will hide my vertices now. So in this case, I'm box selecting this entire body. And if I hit M, the manipulator appears at the center of it. We try to identify the center of mass, let's say roughly, of the selected elements and place it there. And so I can still move everything. So here I'm obviously moving rigidly the entire body. If, however, I select my entire body and then I show my vertices and I select only one vertex and then hit M, then this is an indication that I want my manipulator to be placed exactly at that vertex. And this is very convenient because, for example, if I do a scale, like here, the scale happens around the position of the manipulator. So I'm scaling and keeping this point unmoved. Or if I'm rotating around that vertex. So in short, the move manipulator looks simple, but it has a lot of functionality built in. And it's something that you need to discover slowly. So I think I went through most of my notes about the manipulator, the things that I wanted you to be aware of. And so, so now you know how to use this tool a lot more efficiently and in all of its strength. Yeah, I think that's all I had to say about moving stuff with the move manipulator. Now, let's move on to dimensioning and scaling. We have already seen how you can scale an object. For example, I hit A to select everything, M for the manipulator, and now with the Shift key pressed, I am scaling up and down this body freely. Or without the Shift pressed, I'm doing it along this direction. However, there's also a different way, more controlled, actually two more ways that I want to present for scaling a body and giving it dimensions. One way is what we call a quick scale. So in this example, I will select, you need to select exactly two vertices on a body and then hit the D shortcut. D stands for distance or dimension. So this little window comes up and it tells us that the current distance between these two vertices is 2.75 centimeters. And I can go in and change it to, for example, 3. And I also have some toggles here. For example, whether I want this change to be applied only to the two vertices that I selected, so only these 2 points will move, or to the entire body, so that everything will scale to accommodate this elongation, let's say, or this change of distance of the 2 points. The second toggle is whether I want the scale to become proportional. So instead of just moving in this direction, everything blows up, like we saw before. And the third one is whether I want to lock the first vertex I selected in place. So only the other one will move. So I'll select these toggles. And as you saw, we had a movement of only this vertex here to accommodate the new dimension. One point I wanted to make, instead of selecting the two vertices, you could select the edge that connects them and then hit D. It's equivalent, and in fact, if you see, we replace the selection for you. It's just a shortcut, a convenience for quickly selecting one element of your body, or two if you go for the two vertices, that carries its dimension. Alright, now this was the quick dimension tool. We also have a button up here which is for scaling. And in this case, what we want to do is, for instance, I will select this entire body and I will hit the scale button. The shortcut for this now is Shift D. D was for the quick scale, Shift D is for the more advanced scale. Now in this case, I get this interface where I can specify how I want to scale this body. So, for example, do I want to scale it in its entirety, proportionately, in which case I give a value here in the diagonal distance box, or do I want to scale it along X or Y or Z, as we saw before? And in this case, I chose to scale it all proportionately. Now, if I hide my vertices and I select everything, and I select only two vertices, for example, these long diagonal vertices, and then I hit Shift D, which, as I said, is the shortcut, we see a slightly richer interface. It has these two additional columns, because now that I have two vertices here, I'm giving Phi the opportunity to also work with the distance between them. So I can still specify a percentage by which I want to scale my body, but alternatively I can specify, for example, the new distance. So these two vertices are currently at almost 11.5 centimeters. Let me change this to 17 centimeters. I hit scale and the entire body scaled proportionately to make this distance 17 centimeters. By the way, you may know that when you click on two vertices, you get at the bottom right a little indication of the distance between them. And we do a little rounding there to keep the number of digits small, and sometimes this is not perfect. You can specify how many decimal places you want dimensions to appear with in this box here. So I can change the decimal places to 5 or more. Okay, so this was the scale command. So I think that now I have covered the different ways in which you can specify dimensions for your body. We can move them, we can do a quick dimensioning, or we can do a more complete scaling of the body. So now I want to go into my third and last topic for today, which is positioning things. And for this, I will look into this menu here, the place menu, which has 4 items, and we will consider all of them. Now the first one is just the place button. So let me give a simple example of what this does. I will just select one vertex and I will hit the place button. Now here I'm getting a little interface where I can directly specify the coordinates that I want for this vertex. So for instance, the z coordinate is at 3.82, I want to make it 4. And I can also specify if as the vertex will be repositioned at z coordinate 4, I want the entire body to follow it also rigidly, or if I just want this vertex to move, or any other selected elements to move with it. I will just say this vertex. So it just moved a little bit. I can actually repeat this to make it more clear. I'll make this 6. So it went all the way up. All right. Now, this is the simplest way. If I select more parts of my body, and especially what counts here is the vertices I selected, I will do this. I will select this vertex first, and then these other 3 with a box select. And I bring up the place menu again. Now you will see that it's slightly different. First of all, here at the bottom of the window, we display all of the coordinates of the selected vertices in the order in which I selected them. And then for the x, y, and z coordinate of all of these objects, I am given several options. Either I can leave this coordinate as it is. So whatever the x coordinate of any of these vertices that I selected is, I will leave it as it is. It will not change as I apply this operation. For the y, I will do the same. And for the z coordinate, which is the vertical coordinate, I will not leave it as it is. I will not give it a specific value, but I will select the third option to make it the same as the z coordinate of the first vertex I selected. So I hit set, and sorry, the view was a little, let me do this again because I had rotated and it wasn't, we were not looking with the z coordinate vertical. So now the z is pointing up, so let me hide this. So let me just repeat this very fast. I select everything. I leave x and y as they are, and I make z the same as the first vertex I selected. And as you see, everything moved up, so that now, if I switch in this view, all of the vertices moved so that the z coordinate of all of them became the same as the z coordinate of the first vertex. So if I, for example, move these 2 guys down here, and I move this guy here, and I repeat it once again, because again I'm not very happy with the viewpoint I had selected. And I make z the same as the first vertex. Okay, I think now it was obvious. All of these vertices moved up in the same plane that cuts the z-axis where the first selected vertex was. So it's a quick convenience for moving everything in the same plane. And of course, I can also select, for example, several vertices. And I can choose the other option that we haven't used yet. So I can say place all of these so that the z coordinate is at, so where is it now? It's at 1.6, I don't know, at 2. So somewhere in between the 2, yeah. So both the vertices moved so that the z coordinate became 2. And this is how the place command works. One reminder, if you shift click on any vertex, again you get a little window that shows the coordinate of the vertex you selected. And this is again clickable, editable. So I can make this 2.5 and hit set. And my entire body moved up so that the vertex moved at the location 2.5. All right, so let's move to the next item in this menu, which is the projection menu. So in this case, I will just restart and I will select a cube. I'll shrink it down and move it over there. And I will also bring in a cylinder. So let me look at this from the top. I shift click to select the entire cylinder, M for the move tool, and I will also rotate it like this. Alright, so I have my cube here and my cylinder over there. Now, this second item is for projecting parts of my bodies onto other bodies. So for example, I'm selecting this face here and the edges around it, and I will hit project. And so I get this little window and I have several options now. I can project it onto one or more faces, or perpendicular to one of the orthogonal planes, or along a linear edge, or along the current view direction. I'll go with the first option. I proceed, and then I have to select the target of my projection, and then I have to click the project button once again to complete it. And as you saw, this face was projected and deformed to exactly be projected onto the surface that I selected. And I will repeat it once again, but in this case I will select only an edge. So I want to project this edge, and I will choose another option along a linear edge, and I'll also give it an offset, which means, for example, a negative offset of minus 0.1. So if I proceed, I now have to select the edge that gives me the projection direction. And actually I get a little reminder of this here on the top. So this is the edge I want to select. And again, I complete the operation. And as you saw, this edge was projected onto this body. Let me repeat this. I think that I made a very simple mistake. I will do the projection again. Yeah, I entered my value with a comma, not with a dot. So I wanted minus 0.1 and along an edge and proceed, and this is my edge, and I'll complete the projection. Right. So you see, it was projected, but we have a gap, and the gap corresponds to the negative offset that I gave. If this were a positive number, it would have gone inside the body, it would have crossed through that face. So this is the projection. And the last item I want to discuss is the next one in this little menu, which is the snap. So I select a vertex, for example, and I hit snap, this third icon, and then I select another vertex, and my vertex moves onto it. And I will repeat it now. I will hit snap, and then again the same, but in this case I had the shift key pressed, which means don't just move this vertex, deforming any part of the body that it belongs to, but rigidly move the entire body. Now, I can then select an edge, and again do a snap, and select another target edge. So my edge deformed to exactly snap onto the target edge. And I can do it again, but again, in this case, I will have the shift, I will hit snap, and then I will have the shift button pressed. And in this case, the edge also snapped, but instead of capturing the entire length of my target edge, it only snapped onto the part of the edge that corresponds to it geometrically. And finally, I can have a face. I can hit snap, and then a target face, and my face deforms in its entirety to match the target face. And there is a constraint here, there is a limit here, a limitation, that the target face has to have the same number of edges around it as the face that I start with. Otherwise, we cannot find a way to snap it. I mean, we could do some heuristics, but the result is usually not what the user is happy with, so we decided that better to apply this condition. Okay, and because I'm running out of time, the last item here, it's a tool that we have for working with STL files, with imported STL models. And I wasn't planning to cover it today. I will cover it when we talk about reference objects. You can bring in reference objects from Onshape or images that we have already seen in other webinars, or you can load STL files. And then we have a tool set that allows you to work with these STL files. And therefore, this is something that I will cover in a future webinar. And so I think that this concludes the material that I wanted to cover today. And I'm right on the mark, it's 6:29. Well, my 6:29. Anyway, let me look at the chat. I don't think that there's any questions at this moment. And so, so I think we're done for today. Thank you very much for being here. I hope this was helpful. And let me bring back my presentation. There it is. So, as I said, join us next week, next Wednesday. And as always, if anybody has any design that they want to share with us, you can either send us the Phi file with email, or you can share with us the Onshape document that you're working in if you want. And we'd be more than happy to showcase it or help you work on it or resolve any problems you may have. So thank you very much, and see you next week. That's it for today.